Hello everyone. In this class, we will be using the flipped classroom model, which is a bit different from traditional learning. Instead of starting with lectures in class, you'll be first exploring the key concepts of your own through videos and recording materials. Yes, we have an exclusive video material for learning convolutional neural networks that encourages active learning, where you'll get a chance to dive into materials independently, which will help you understand the concepts more deeply and prepare yourself for real world applications.
Today we are going to discuss about convolutional neural networks, also called as CNN, which are one of the most popular deep learning architectures used in computer vision tasks like image classification, object detection, and facial recognition. CNNs are designed to automatically and adaptively learn spatial hierarchies of features from input images. There are various applications of CNNs, widely used in real-world applications including computer vision tasks that comprise CNN's power image classification systems that can automatically categorize objects in photos, which can very well see in Google Photos, Facebook, Instagram, and all social media. There are various crucial applications of convolutional neural networks in medicine and healthcare. Yes, medical image processing is one of the major areas in CNN where variety of innovations are being carried out. One of that is detecting diseases like cancer by using X-rays or MRI scans. Additionally, CNN are used in self-driving cars that in autonomous navigation systems, tasks like recognizing roads, segmentation of roads, detecting pedestrians, fast-moving car detection, vehicular advanced networks, and many more applications have its base and core in convolutional neural networks. Let's see the operation of CNN. The key concept of CNN is the convolution operation, also called as compressing a huge image into a small forum by using something called as a filter or a kernel or a nucleus. This particular kernel acts among scanning small patches of the images using filters, which helps capture important patterns like edges, corners, textures of different positions in the image, and getting it compressed by using a technique called as convolution, which compresses the image to get only important features. This particular kernel moves across images by using another factor called as stride, which makes the overall convolution process on an average. This convolution process can also be paralleled by using an activation called as a ReLU. Once the convolution operation is done, we apply an activation called ReLU, which stands for rectified linear unit. This particular ReLU activation is used for removing negative values that is being carved out after the convolution process. This removes the major problem of convolution called as vanishing gradient problem. After convolution, the most important layer that follows is the pooling layer. This particular pooling is always used to reduce the spatial dimension of the feature map using convolution technique. This particular spatial mapping is required just because in order to make the normal convolution operation, which is highly dependent on dimensions, and this pooling operation is used to make it size invariant. The most common is max pooling and other one is called as average pooling. We will see most of those in the subsequent classes. Pooling also helps the network recognize features like particular edges, textures, and regardless of their quotient in the particular image.
To learn more about convolutional neural nets and its practical concepts, mathematical constructs, and many more related to CNN, I have attached here with the list of videos from my own channel exclusively for my students who are learning with me the convolutional neural networks and its practical applications. In the next class, we will be having a group activity where you will work in teams to apply what you have learned. Each group will be given a dataset of images that can be benchmarked or customs or those with fun images as well. And your task will be used to implement a basic CNN model to classify those images. This hands-on activity will help you in better understanding, and we'll be using an additional pedagogy called as CAD, which will make you to endorse your own achievements that is performed within your group. This activity is also very much useful for encouraging peer learning and have a strong debate in technical context as well as learning CNN practically. Thanks.
Let's see more about convolutional neural networks in our subsequent video. Be prepared for the next class. Thank you.